and also et will be x, as you can see, and then plus 2 times e of t, which is going to be x, plus a constant of integration, and that's the I that I'm telling you about. So it's an nx to the power of 2 times x minus 2, replacing t by ln of x, replacing e to the power of t by x, e to the power of t, which is x, plus a constant of integration, which is, as you can see, it's just making the right change of variables for your problem, and you will have it as you can see. Once more, it's very, very simple. I would like to show you the other problems, which is really also with the same shape. All you have to do is to just manipulate the part that's causing you the problem, and it's gonna be really, very simple. So in this problem, I think it's a good thought just to consider the root of 2x plus 4 equal to. Let me solve it with you, okay? As an example also. So it's really, very simple. I is going to equal to the integration of ln the square root of a 2 over x plus 4 with respect to 2dx. Well, I have plenty of ideas. I can simplify this problem before we start the substitution, considering it I is equal to half the integration of a ln of a 2 over x plus 4 with respect to x. And in this case, get rid of the power of the argument, because we know that if I have ln a to the power of b, it's equal to b times ln a. This is the property that I took an advantage of it. As I told you, if it is not clear for you, this is just ln to x plus 4 to the power of half with respect to the x. So half just only jumped outside our integration sign. Now I have plenty of ideas. I can use integration by parts, and also if I want to use substitution, I can simply consider 2 of x plus 4 is equal to t, which of course we're gonna need to. That x is gonna equal to t minus 4 over 2, and that leads to that dx is equal to dt over 2, as you can see. Now I can do the substitution exactly as I show you, which is gonna be I equal to, this is the half, the integration, and this is gonna be, and then I will change 2x plus 4 to t, so it's gonna be ln t times, I will replace dx by dt over another 2, so this number is gonna be 4. And from here, I will consider the integration once more. I will integrate by parts my problem once more. Considering ln t, the function to be differentiated, and it is time 1 and 1 will be integrated. So if I like to do this, it's really very nice. It will be I equal to integrate the one which is going to be x, which is going to, of course, remark about this mistake. If you are integrating with respect to your variables, be careful from this. So integrating one is going to be t times the other part, which is going to be ln t, all of them divided by 4, then minus integration. The factor or the number, I can leave it outside, which is going to be 1 over 4. Then I will have t times the derivative of ln t, which is going to be 1 over t with respect to dt, as you can see. These two parts will eat each other. So once more, I will find t times ln t over 4 minus 1 over 4. Remark that the integrand is just only 1. integrating one, which is t plus the constant of integration. And don't forget that you will need to reverse your substitution. So by the end of my problem, I will replace every t by 2x plus 4. So actually, the result will be I will be 2 over x plus 4 times ln over 2x plus 4. All of them are divided by 4 minus 1 over 4, and still I have t, which is once more 2x plus 4 plus the constant of integration. As I told you, it's really a very simple way in order to conduct your integration, but you will have to focus. Okay? So choosing the right way to integrate, that's the key in solving these problems. And once more, as I told you, I'm repeating myself, please try to resolve these problems once more by your hand. It's measure the ideas that will come into your mind by getting the skill of solving plenty of problems. So it's really very important to do it. The final problem in this slide that I also would like to show you, and it's one of the famous substitutions. It is the function with root of x with respect to the x, which is divided by the root of x minus the cubic root of x, as you can see. And in this case, I will need to think about a substitution that will break all the radicals that exist in this problem. So I'm not gonna make the substitution of x equal to t to the power of 2. Of course, t squared will break the square root, but you will stuck with the cubic root. And if you choose x to the power of 3 or t to the power of 3 in order to break or to escape from the cubic root, is also gonna head back to you in the square root. So why not to choose something that will break both of them? Why not to put each x equal to t to the power of 6? Why t to the power of 6? Because actually it will break both of them. But the price should be paid. The price will get back to you in the value of x, which will lead to Mr. Ahmed. That dx will be 6 t to the power of 5 times dt. You can see how delicate it is. In the same problem, you are integrating, you're finding the differential, you are applying. It's really very important. So now I will start substituting. So it's going to be the integration. I will replace hx by t to the power of 6. So it's going to be t to the power of 6, and the general power is half with respect to 2. I will replace dx by 6t 5 dt. Then I will go down. Of course, you will have your cubic, root, but inside it you have t to the power of 6 minus, you still have square root, but inside of it you will have t to the power of 6. So simply the integration will be, if you try to simplify everything, you will have the following. This is 6, which is outside. This is going to be t to the power of 3 times t to the power of 5. So it will come to t to the power of 8 divided by dt. And then for the denominator, you will have, for this guy, it's going to be t to the power of 3 minus t squared, as you can see. So the problem really changed. But also, you can't integrate. Why I can't integrate? Because we spoke about this in the previous sessions. That's an improper fraction. So you will need to come up with something in order to go over this issue. I will try to simplify it as much as possible. So I will take t squared from the denominator and from the denominator in order to make my life a little bit easier. So it's going to be t to the power, I believe, 6. If we eliminate t to the power of 2 from both the numerator and the denominator, so it's going to be t minus 1. Then I will have to stop and to do long division in order to be able to separate the fraction than the other function. So all I have to do now is to make a long division, dividing t to the power of 6 on t minus 1. It's very simple, but it's a lengthy process. But it's very simple. So t to the power of 6 on t will leave you with t to the power of 5. Multiply once more, it's gonna be t to the power of 6 minus t to the power of 5. It's just to replace and put a negative sign. Then you will have once more t to the power of 5. Then once more start to t power 5 over t. It will leave you with t to the power of 4. Multiply once more, so it's gonna be t to the power of 5 minus t to the power of 4, and then you will have minus, of course, you will have once more t to the power of 4, which will add t cubed, multiply, it's gonna be t to the power of 4 minus t cubed, negative sign, and then once more t to the power of 4 minus t to the power of 4, they will cancel each other. You will have t to the power of 3 on t. You will have t squared, once more multiply in all the elements, t squared times t, which is going to be t cubed. T squared times 1, negative 1, it's going to be negative of a t squared. Replace the sign, then add, it will be t to the power of 2. Dividing the t, it will be t times t. So once more t squared minus t to the negative is just only t. On t, it's going to be plus 1, and then multiplying, so it's going to come up to also t minus 1, as you can see, and then you will have u1. So now I can replace this integration to be, that's the 6, and then I will change the integrand by the quotient, which is t power 5, plus t to the power of 4, plus t to the power of 3, plus t to the power of 2, plus t plus 1, and don't forget the remainder, which is 1. It's gonna be 1 on t minus 1. Here the integration or the price is very simple, because the integrations is just like that. So integrating, which means I is gonna equal to 6, open your bracket. This is gonna be t to the power of 6 over 6, plus t to the power of 5 over 5, plus t to the power of 4 over 4, plus t to the power of 3 over 3, plus t to the power of 2 over 2, I'm talking here, plus integration of 1, which is going to be t. Okay guys, 1 over t minus 1, what's the integration? Len of a t minus 1. All of this was the constant of integration. Okay, but don't forget that the price is not just only paid yet. You will have to make the replacement once more, replacing every x by t to the power of 6. So actually, t to the power of 6 will be replaced by x. And from here, every t is equal x to the 1 over 6. I will go through each one of them, replacing every t that exists in my problem by x to the power of 1 over 6 in all the terms. And this is how you integrate this function. As you can see, for this part, we took now a lot of integration ideas, starting from the first or the direct formulas. This is number 1. Okay, then we did go through how to break through partial fractions, then how to use integration by parts, which is very important. Then finally, the integration by substitution. And as you can see from the previous problems, all I had to do is to just make a substitution. Then the problem will get back to one of the previous ideas, exactly like this one. Don't mind the length of the problem, but it's still durable and you will be able to solve it. But you need, as I told you, the skills to do all of this. It's very important, as I told you, to try to solve as much as you can from these problems. This is really major. Okay, now I will go to continue to the entrance of the integration, okay, using the definite integration and the meaning of these items. We will go through the Darboux integration, the mean value theory for integral or the Lagrange. Don't let the names fool you. It's all of them, they are very, very simple. Okay, indefinite integration and the relations in indefinite integration, fundamentals theory for calculus, and I believe I will leave the improper integrals to the next session, inshallah. So, if we need to start, the idea is very, very simple. I need to evaluate the area between this curve and this axis. I need to evaluate this area accurately. So, if I want to do this, I need to determine the area enclosed between the graph F and the x-axis starting from A to B. One of you will think, and you will tell me, well, I think we can do something very, very nice. We can break this area into small slices like this, okay? And in this case, I can get the slice, which is HB minus A over N. So for n slides, I can get the widths of each one of them. And it's really very close to be a rectangle, which is gonna be H, which is the widths of each one of them, times the height. But unfortunately, I have two heights, this height and that height for this slide. So I'm in between considering these bars like this, and in this case, I will go with the smaller rectangle inside my my graph. As you can see, it is all of these triangles. I will evaluate, I'm sorry for these rectangles, I will evaluate the area of each one of them. That is really simple, because the area for this one, for example, it's gonna be H times the value of the function controlling, if this is f of x, for example, it's gonna be f at A. Then I will add on it the second one, okay, and the third one, the fourth one, and so on. But from a look of an eye on this, my evaluation will contain an error. And this error will lead to an area which is less than the given one. And also Mr. Ahmad suggested that we can take the upper, as you can see, the upper rectangles. And also still we will have an area that's not actually 100% representing, but it's going to be very close, but it's going to be a number that's greater than the intended area. And actually, those are the okay, so once more, those are the dark boxes that we talk about. This is if we talk the smaller rectangles, as you can see, in order to evaluate the area from A up to B. And in this case, this is going to be the professional form, which is f, the value of function, the minimum of the two values, times h, and you will have a summation for the n slides that you made. Okay, it's really very simple, and that's a more clarification for h, which is b minus a over n, and how to evaluate or the simplification or the symbols, how they are described. Also, we can take the larger values, and this is going to be the case. And it will make no difference. It's going to be exactly the same, but instead of having the minimum of the values of the function at the end and at the beginning, I will take the maximum of them. This is the dark box sum, lower and the upper dark boxes. As you can see, there is a difference between them. If in particular we were interested in inserting exponential function, let's say e to the power or 0.15 of an x in specific, so I'm talking about in specific of handling e to the power of 0.15 of x. This is gonna be the case from A to B. Okay, if we consider A from 4 up to 12 or something, this is going to be the value of the dark box if you consider one dark box. That's going to be the value if you consider the minimum dark box for this issue. And this is going to be the exact evaluation if you evaluate this function correctly. Of course, as much you make your slides or you increase your slides, you will have a suitable, more suitable and approaching the correct answer, but still it's an approximate value. Okay? So once more, that's the relation that you can see controlling all of these three cases. That's the mini, that's the maximum, and that's the accurate case inside both of them. From this point, we come to the Lagrange, which is an abbreviation for the mean value theory that we already talked previously in differentiation, and in integration exists also. So in integration, the mean value states the following, or the Lagrange states the following. If f such that it's a function defined on AB, and it's a continuous function within this interval, then there exists C belongs to A and B such that the integration from A to B f of x dx equal the value of f of C minus, times B minus A. Which means if this is your function, okay, I can find a value of C at which the value of the function can approximate the tops and the lower parts of your curve. And so it can be multiplied or considered as a rectangle. That's the beginning of the idea, of the main idea, okay, of definite integration. So it came from this point. This is also an idea for a very nice problem like this one. We want you to consider the function which is running from R to R for 6 of x divided by 2x squared plus 1. Remark that at the time being, in our opinion, you've studied most of class 1, so you are a professional at the time being. You know how to discover if the function is continuous or not, if it is differentiable or not. You can find the limits in plenty of ways, either in R to R and R2 into R star, in vector valued functions. So you are an expert at the time being. So, consider the function which is f running from R to R for an f of x, which is 6x over the root of 2x squared. He wants you not explicitly computing. Yeah, don't go through the details of computing, but it just justify why you may assume the existence of a C belongs to 0 and 2. He wants you to justify the theory of Lagrange. It's very, very simple. So all you have to do in this case is to prove that your function is continuous within this interval. And of course, if you give it a bigger look for the function, of course, this is the Lagrange that I want to prove or find, which states that from A to B f of x dx, the value of your integration is simply b minus a times f at c. Okay? So I need just to check. Remark that this is 0 and that's 2, so that's 2 minus 0, which is 2 times f of c, the shape of the function. So all he is asking you, is it already exist? It will exist if the conditions exist. This is why, let's verify that 6x over the root of 2x squared is 1 plus 1 is continuous. It is continuous. Why it is continuous? It has a denominator, صح? It has a denominator, so the only obstacle that you have a denominator, but it's a well-behaved denominator. Because if you look to the denominator, you will find 2x squared plus 1. And 2x squared plus 1, it is always positive. Not just only positive, it is always greater than or equal to 1. You are in a safe place. And we are not talking about the whole domain. The whole domain is safe, of course. But I'm talking just only between 0 and 2. So there is no discontinuities, it's a continuous function. So I can apply directly the theorem of Lagrange, which means from 0 to 2 f of x dx, it will equal to 2 minus 0, and there is f at c, where c belongs to the interval from 0 and 2. It's really very simple. Now I've answered this question. Once more, in the indefinite integration, if I have ax, which is running at the boundaries from a to x for f of t, and dt. In this case, I will be able to evaluate this area. A is a function in the x value or in the variable between a and b. It's very simple. All I have to do is to integrate f of t dt, and it's running from a up to x, which is really a piece of cake. If f is continuous, or if it is bounded with a finite number of discontinuities, then it is integrable function, and we can find its integration. The fundamental theory of calculus part 1 states that if you have a of x, which is ax f of t dt is continuous in ab, and the a dash x equal to f of x, which is the main concept of an integrated function. If you differentiate, you will get your integrand. For every x belongs to a and b, then remark Mr. Mohammed or Mr. Ahmed, in a to u of x f to t f of t dt, then a dash of x, the gradient or the first derivative of this function, which depends on x, it's going to be really simple. What you have to do is to replace t by u of x times the derivative of the power, as you can see. Since it's just a fragment of a question, I will show it to you in more than one problem. For example, for this problem, I want to find the gradient or want to find the derivative. So simply, I need to find g dash. G dash is very simple. G dash of x is gonna be f of the upper bound, which is 2x, times the derivative of 2x, which is 2. So actually, g dash of x will be 2 times f of 2 over x, and that's the gradient vector for this problem according to this theory. As usual, before we continue to another more problems, I would like to show you the shape of the function. So once more, this is the law, g of x from a up to 5x f of t dt. So in order to get g dash of x, just to make the replacement, replace t by 5x times the derivative of phi, which is phi dash. That's the rule that we are going to follow. So just applying, this is going to be f of 2 of x times 2. I believe I've actually put plenty of problems in order to make it easier for you. For this problem, for example, if I want to find g dash of x, do the same, Mr. Ahmed. So it's going to be f of x times 1, because the derivative of x is equal 1. So once more, that's g dash of x is going to equal to f of x directly. I've replaced t by x and differentiated x, which is going to equal to 1. Once more, g of x, it's from 3 to x, f of t dt. Find g dash, it's also very, very simple. Once more, Mr. Mohammed, I will replace t by x, then times the derivative of x, which is equal to 1. Once more, it's going to be f of x, as you can see. Okay, let's see this one. It's from 0 to x squared over f of t. So the result will be f of x squared times 2x. Yes, it's already over there, as you can see. This is also 1 sine x f of t dt, which is going to also be really, very simple. It's going to be f of a sine over x times the derivative of sine, which is cosine over x. It's really very simple, as I told you. What if the variable was on the lower limit, not on the upper limit? In this case, I will add negative value, because actually you are making substitution. So it is f at 5 times the derivative of 5, which is 0. So the first part will be cancelled. And then I will have minus f of x times 1. So the answer is negative f of x. Once more, if you want to also get trained on this bar, this is 4x squared, and that's f of t dt. So once more, g dash of x is going to be f of x squared times 2x, but with negative sign, as you can see. Here's another problem. This is f of t dt, and it's running from x up to 2x. Once more, it's going to be f of 2x times 2 minus f of x times 1. I've made the substitution by the upper bound and the substitution, but minus the substitution by the lower bound. So in a more practical problem for this one, if I want to find the derivative, anyone? So J dash of x will be
f of
f
x
squared times
2
minus, okay, yes you are right, cosine x, and this is f of sine of x, as you can see. It's really very simple to apply. In this case, we didn't take much complications, so it's going to also direct, as I told you, direct answer in this case. This is again the arithmetic function and the e to the power of x, so this is going to be f to the power of ln 1 plus x minus f of e of x. This is going to be the case, as you can see. Also, this is the case that we used in the previous problems. I thought just to share the slide with you, so if you have variables on the boundaries of your integration, just make the substitution, but don't forget to multiply by the derivative of these limits. This is also direct substitution. I believe now you can solve in one of them. So the first is going to be very, very simple, which is j dash of x. So, am I right? It's going to be f of x cubed plus 1 times 3 over x squared minus the second part, which is going to be f in e to the power of 2x. Don't forget that I'm differentiating, so it's going to be 2 to the power of 2 over x, as you can see. Of course, be careful, because if you have multiple choice in these problems, you need to focus. They will be close to each other, and maybe we can manipulate any one of them, so you will have to focus in order to solve these problems. Okay, that's the general rule, okay, in Bohr's formula for identifying or finding definite integration. I usually integrate the function inside the integration, then making the substitution by the upper bound minus the lower bound. That's the general theorem for applying the indefinite integration. In this problem in particular, he wants you to find the value of c in order to approximate this relation or to prove it. It's very, very simple. He wants you to consider the function f of x, 6x over root of 2x squared plus 1, the previous example, and not explicitly computing it, justify why you may assure the existence of c belongs to 0, 2. We already did that previously. The function is continuous, as I told you. So for sure, I will find certain value c belongs to the interval. So the first part is already there. The second part is really very simple. Of course, that's the first part, and I'm going to the second part directly. The second part states that first of all, now I know that f of x dx from 0 to 2 is equal to 2 over f of c. I can evaluate this integration. Okay, so any ideas how to integrate using the given integrand? I want to integrate, yes, from 0 to 2, 6 over x divided by the square root of 2x squared plus 1 with respect to dx. Yes, Mr. Omar, of course, this is really a very simple problem, because simply I will equal to integration from 0 to 2, and I have 6 of x times 2 over x squared plus 1 to the power of negative half with respect to dx. So now I've changed the shape of my integrand. I need to be sure about the condition, as Mr. Ahmed of course said, that I need to find the derivative of this function in order to integrate. And the derivative is simply 4 of x. Do you have 4 of x in here? Yes, of course. We can find it by taking 6 outside, so it's going to be 6, dividing on 4, and then multiplying on 4. So it's 0 to 4 of x times 2x squared plus 1 to the power of negative half with respect to the x. So the integration will be I equal to 3 over 2. Then I will integrate this bracket by adding 1 to the power and dividing on the new power. So it's going to be 3 over 2, then times 2 over x squared plus 1 to the power of half, and then dividing on half. Once you divide on 1 over 2, it means you multiplying by 2. So this is actually the value of your integration. Then I will substitute by the integration limits, which are 0 and 2. Replacing every x by 2, which is going to be 2 to the power of 2, 4, times 2, which is going to be 8 plus 1, which is going to be 9, under the square root. Then I will do the same, but with elimination of leaving 1 and taking the square root of this guy. So once more, if I want to integrate, it's going to be really, really simple. Okay, once more, this is going to be half, it's from 0 to 2, 6 of x. So as we did exactly, raising to 2x squared plus 1, trying to arrange the terms, multiplying and adding, you will have 9 minus 3 times x, blah, blah, blah. So the result of integration is 6. Now I will get back to this rule. This part is equal to 6, am I right? Which is equal to 2 times f of c, which means f of c is equal to 3. Once you have f of c is equal to 3, you come to this result. I'm sorry. This is f of c, which is equal to 6, as I told you. Okay. This is just a second, please. I'm sorry. We started this integration by multiplying of 1 over 2, so we already get rid of the half at the beginning of our problem. Okay? So what I mean now, I have the value of f of c, which is 3. I forgot that we already divided. So in order to get f of c, use the mean relation, replacing x, so it's going to be 6c over the root of 2c squared plus 1, which is equal to 6. Try to solve for the value of x. So this is actually what I have in here. So make a cross multiplication and square both sides and try to